right, this is the Geometry SOL 2013 solutions. All right, so number one, let P represent two angles or vertical angles. So that's P. Q is the angles are congruent. What is the symbolic representation of the following statement? If two angles are congruent, that's Q, then, remember that's our arrow, the angles are vertical. So Q then P. So you should have selected A. Okay, Beth. She is drawing a perpendicular bisector of ST. Remember, a perpendicular bisector is going to form right angles and form two congruent parts. All right. So to do a construction like this, what you would do is you'd get out your tool, your compass. Let me find mine here. Compass. All right. To draw a perpendicular bisector, you're going to start with your point on T, and you're going to draw an arc above, let me change the color, above and below the line. You're going to come to S and do the exact same thing. Above and below. Okay, so once we do that, I can get rid of my compass, and now I'm going to construct a straight line through those 2 points of intersection. Oh, well, it didn't work. There it is. And now what point is on my perpendicular bisector? Correct, point Z. Okay, so there are some you would have to know how to do the constructions, but a lot of them you could also sit there and you use your ruler to find your middle and just look to see what's going to line up. Because if you would have used your ruler, let's grab the handy dandy ruler out. What did I say? Oh, I said Z. Oh, goodness. Thank goodness I have a student today. It goes straight through X. Why did I choose Z? It goes through X. If you would have used your ruler, okay, you'd have known that it's 35, because 10 to 70 is 35, and then we want to go 1, 2, about 37. Okay, so it's going to go through 37. If we would have marked that little point, then we could have, well, why is my little point not working? Right here's 37. Oh, it did work right there. Now let me get rid of this little thing. Close. You drew your line there, you can see what goes through that line. So there's still lots of ways to get through it. All right, number 3. In the figure, parallel lines A and B are intersected by line C. Which pairs of angles is not supplementary? You can do the box method, you could do the star and triangle method. Let's do a star. What angles are congruent to angle 1? 4. What else? 5 and 8. You got it. And then these, I'll just do like a circle. Okay. Which ones are not supplementary? Remember, stars are all congruent. All the stars are congruent. All the circles are congruent. What can you guys tell me about a circle and a star? What can you guys tell me about a circle plus a star is going to be 180? Okay, so then look at this. 1 and 6. Are they supplementary? We have a circle and we have a star. They are supplementary. And we want what's not supplementary. 3 and 8. Circle, star. That works also. 2 and 7. Circle, oh, circle. Let's not stop there. Let's keep going and check. 4 and 6, because we could have easily made a mistake to begin with. Nope, they're supplementary. So our answer should have been 2 and 7, they are congruent. All right, any questions about that? I'm going to move that up here so I can see what's going on. Okay, number 4. What type of construction is illustrated in the figure? When you have this little X right here, that means you're going to draw a line through there. And we're going to draw a line from point D to that X. So let's see. Did I bisect angle D? Did I bisect segment BD? There's not even, BD doesn't even exist, so that's definitely not. An angle congruent to angle D? No. A line segment congruent to AB? No. So guys, you all could eliminate the majority of those answers for constructions. We bisected angle D, because remember, bisection is 2 congruent parts. All right, number 5. Woohoo, number 5. All right. This Venn diagram represents students who play instruments in the orchestra. Oh. Identify each region of the Venn diagram that represents students who play only the flute and the oboe. So if they play only the flute and the oboe, then they play both. So flute is all this circle. Oops, I'm not a good drawer. Oh man. I have to do something with that. This circle is flutes. I'm not a good tracer either, evidently. And this circle up here is oboes. Which number plays both flute and oboe? Plays only flute and oboe. Which one? 10, you are correct. Okay, be sure to have faith in yourself because you are a smart person. Oh, next page. An angle congruent to angle A is being constructed. Which ray could be drawn to construct an angle congruent to angle A? Well, let's get our handy dandy utensils out. And we want a compass. And I'm going to reflect it. There we go. So I'm going to put my point on A, and I'm going to draw an arc through that angle. Oops, I want to get rid of that, and I want to draw a line through that angle. Oh, that's pretty cool looking. Okay, so I'm going to come over here to B and do the exact same thing. All right, and then from this point of intersection, I'm going to put my point here. I'll just move up here. Now let's just stay down here. Put my point here, and I'm going to rotate up here. Oops. Well, and that's going to be my point of intersection. So come down here, and I'm going to use that to measure my angle. Okay, close it, and what I'm going to do is draw my segment from B through that point of intersection. Okay, honestly, could you have just said, hey, let's just draw these and see what happens? Sure, let's try it and see what happens. Uh-oh. Let's say we want D. D looks a little bit bigger, don't you think? F, still a little bit bigger. E, we can tell that one gets smaller. So you can also graph those in first too, if you'd like. But C should be your answer in case you forget how to do constructions. So your segment should be B, C, you're right. All right, number 7. Which diagram shows a pair of angle measures that proves lines A and B are parallel? Well, I'm going to go through here and I'm going to highlight lines A and B. line A, and line B, and line A, and line B, and line A, and line B. You guessed it. All right, for those two lines to be parallel, we need a box going through one of the lines. We need a pair of special angles or a pair of measurements that are going to make them the same or supplementary. This one down here is 120, and up here at the C, that one's 120, but that doesn't tell us the lines are parallel. It would have to be something here and here, or here and here. All right? If we look at C, this is 120. In order for these two lines to be parallel, this would have to be 60 up here, or 120 down here. So that one doesn't work either. B, this is 120, over here is 60. If I correspond my 120, this is going to be 120 right here. So these two angles are supplementary. They form 180 degrees, so B is your answer. All right, number 8. Whoops, next page. Number 8. Which is a valid conclusion that can be drawn from these statements? If a quadrilateral is a rhombus, then it is a parallelogram. If a quadrilateral is a parallelogram, we're repeating Q, then its opposite angles are, gotta get to class, then its opposite angles are congruent. So your conclusion is going to be, your parallelogram is going to cancel. If a quadrilateral is a rhombus, then its opposite angles are congruent. So what's that one going to be? Opposite angles of a quadrilateral are congruent. That works because we're saying quadrilateral, and then we're saying they're congruent. Whoops, that should be green. Okay, so we're saying P, then R. Good job. The figure shows parallel steel railings through points M, N, P, and Q. So all these lines are parallel. What is the value of X going to be? 61. You are correct. Okay? These two angles are corresponding, so it's 61. They stay on the same side of the transversal, and they're on the right side of the they're on the same side of the parallel line, and they're on the right side of the transversal. So 61. You guessed it. Number 10. Given S is -1, 8, and T is 7, -9, what is the length of ST? We need to do the distance formula. Square root of y2 minus y1, so -9 minus 8, squared plus 7 minus -1. Okay? -9 minus 8 is going to be -17. Squared plus, oh, I forgot my squared up here. Since I subtracted negative, we're going to be adding, plus 8 squared. And the -17 squared, we're squaring a negative, so it's going to be positive 289. So the square root of positive 289 plus 64, because 8 squared is 64, and that's going to give us 353. All right, that's your answer, square root of 353. Is there another way you could have done that? Oh, you jolly well betcha. Let's form our right triangle. Okay, here's our right triangle. We can do the Pythagorean theorem. We can count how long the triangle is and how tall it is. 1, 2, 3, 4, 5, 6, 7, and 8. And it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 units long. So you could have just done 8 squared plus 17 squared equals x squared. And see, we're at this point right there. So 64 plus 289 equals x squared. 353 equals x squared. Take the square root, and x is square root of 353. Isn't that just the coolest? That's what I love about math. You can do things more than one way. Number 11. Line T contains these 2 points. Identify the points other than point P with integral coordinates that is in a line parallel to T and passes through P. That is so many words. We're just sitting here like, what? All right. All it's saying is line T contains these 2 points. Identify other points on the line that is parallel to T and goes through P. So let's find our slope. -8, 5, and 8, -3. You're going to rise 1, 2, 3, 4, 5, 6, 7, 8. Oops, can't trace the line. So I rose 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You're not in class now, you're late. So my slope is equal to, and it's a negative slope, -8 over 16, which is -1/2. Remember, -1/2 is the same thing as saying -1 over 2 or 1 over -2. All of those say the exact same thing. And parallel lines have the same slope. All right, it's got the same slope.